Okay. You're going to hit at the end of this assignment, after you practice simplifying and factoring things, you're going to hit a few problems that say verify. Okay? What does it mean to verify something?
To prove that it's true.
To prove that the two sides are equal. Well, it's not checking. So, I'll give you a nice one to start with here to verify. This is a nice, pretty one. They're going to give you something like secant of theta times the cotangent of angle theta times the sine of angle theta is supposed to equal 1. You have to verify that this really equals 1. Yes, ladies? Okay, now, you have to know the rules. When you're verifying, you are not allowed to move anything across the equal sign. You can't add something to the other side. You can't multiply something to the other side. The equal sign is a barrier. So, I have to use the identities, and I have to change it into things. In this case, if I need to equal 1, I need to get it to cancel.
1 over cosine.
All right? Cody says secant's 1 over cosine. I can buy that. Okay. Question. Do I want to change a cotangent into a tangent? Is that going to help me? Okay, realize when you have cotangent, you've got number 3 and number 5. You only use number 3 if you're trying to get your problem all into tangents. Otherwise, you'll use 5. So that would be cosine over sine. And then, do I want to change the sign? No. Usually, you'll want to change things into sine and cosine. So if it's already a sine, don't change it. It's happy.
1 equals 1.
And then, yeah, once I cancel, cosines cancel, sines cancel. I'm down to 1 equals 1. Okay, you must show me, get it down to where you have the same thing on both sides. You have something equals something. Show that it came out equal. Okay, you are allowed, in this case, we only needed to work the left-hand side. There was nothing we could do on the right-hand side. You are allowed to work on both sides if you want, if there are two sides. You can?
That is, but it don't make sense why
Oh, really? Okay, interesting. Well, you can break the rules here then, I guess. Have you done these before? All right, so let's try one with a touch more pizzazz. I think that's supposed to be a line. Okay. All right, here's another one. You have to get those two sides to come out equal. This is where it's like a puzzle. You got. And by the way, I should tell you, many of these problems, there's more than one way to do this. So if you're talking to somebody else, they may have done it a different way than you did, and you can both be right.
Grading period time takes a really long time.
I have to go through every piece of work on these.
So we probably don't get very many.
And the other thing that I notice happens, people get it worked, and they're close, but it didn't come out quite right, and then somehow their answer just magically changes into the right thing.
How's that happen?
I don't believe in magic wands, so I will notice if you just magically change it and make it come out equal. Yes.
My question is, will they, the ones that you,
Yeah.
the ones that you will give, will they always come out equal, or
Yes.
are you
Yes.
okay?
They will always be equal. I'm not going to give you one that doesn't come out equal.
Okay.
They cannot come out equal. They are equal. I guarantee you they're equal. So, yes, I'm not going to be mean to you.
We're not actually verifying it.
Well, you're verifying that this is true. I hate to tell you this, but this is what most mathematical proof is. You prove two sides are equal. The proofs you do in geometry are only like geometry. Most other mathematical proof is truly set and equal. In this case, this is just a way to get you to learn to use these identities and manipulate them. You've got to have practice with them, and this is the best way to do it. So, this one you'll notice has 1, 2, 3, 4 different trig functions in it. If you see a problem with this many trig functions in it, you need to change it to sine and cosine more than likely. If it's got that many, get it into something that's in common. Okay? So, there's several ways you can go with this one. I'm curious what strikes you as something to try?
Start left and work right. You guys think it's square though. Start left and work right.
Okay.
Like, yeah.
It actually, you can start left and work right, but sometimes you may notice something. Adam just noticed something that's going to help us. He said change cotangent into cosine over sine, and change tangent into sine over cosine. Why? They cancel out. So now, is that gone?
So which one?
So you know you're going to have a something minus 1. So now we just need to figure out what this... Okay. Luke wants to change tangent squared into sine squared over cosine squared. He's using number 4.
Well, then we can change secant thingy. Change secant.
Okay. So, and remember, on the first 5, you can put in whatever power you want on them. It's legal to change the exponent. So what are you thinking you want to change 1 over secant into? It's not written up there, but it's there implied. Why is it cosine?
Because if you could do the same thing by
It's number 2, just the other way. 1 over secant would equal cosine, they're reciprocal.
You've lost me.
So you can have this as secant equals 1 over cosine, or cosine equals 1 over secant. They're reciprocal. So yes, you're right. You can change 1 over secant into cosine squared since it's got a square on it. Okay, yes, you're okay. So now, what cancels? Cosine squared is gone. So I'm left with a sine squared of the angle minus 1, and it's supposed to be equaling negative cosine squared. Okay, now, Cody, be quiet, number 1, and number 2, this is a trick you need to notice. It's got a sine squared and it's got a 1. So it's sort of like number 6, but you'd have to ask yourself, could I rearrange number 6 to say sine squared minus 1? Yeah. So if I bring the 1 over here to the left-hand side, then the cosine squared would move to the right side, so it would become negative cosine squared. And so sine squared minus 1, is equal to negative cosine squared, and we just proved this thing's equal. Okay.
So do we actually work getting it from there to the last step?
If this is just carrying down and you're never changing it, you don't have to keep.
The second last step and the last step. That one and that one.
Well, no, by showing that it went from here to there, that is the work.
There's no, you're not showing, okay.
Sine squared minus 1 is equal to negative cosine squared. That's the work you can show. That's all you can do with it. So, get the feeling for how much fun these can be?
I like it.
It is. Oh, I see my note here. Please, I will take off points. Y'all listening to this? You must, when you're verifying, you must work downwards. When you work from this line, then you're changing it, goes to this line. Do not take one of these and start writing across, and then take the other one and start writing across. I have to be able to follow it. You work downward. Don't work across your paper. It's impossible to follow what you're doing. So when you change this line, then you write when you change it into below it. Don't write it beside it. Go down.